I am Chaitanya. My roll number is 108117053, and we are doing the project about the detection and identification of physical layer attacks and optical networks using machine learning. Okay. So, coming to the contents, these are the contents: introduction, objectives, proposed methodology, results and discussion, future plan for the second review, and references. Okay. So, coming to introduction, optical networks. So, what are optical networks? So, optical networks, they were simply the communication systems through which we can transfer the information from one end to another end through optical fibers, simply through light. So, the information which we are sending through these networks might be a very crucial one, and we need to make it secure. So yeah, and obviously there comes the attacks which are possible on these optical networks. So some of the attacks we actually mentioned in the previous review about the in-band jamming attack, out of band jamming and the polarization modulation attack. Yeah. So these attacks at times they even become really hard to identify or to detect these attacks. So we need to find a solution to identify them and to restrict these attacks from happening. So, and even when we can see that these optical layer security issues, they even become more significant when coming to quantum key distribution and space division multiplexing, because these are really highly sensitive to physical layer disturbances, which happens due to these attacks. Yeah. Yes. So coming to the objectives, so these are the things which we are doing. So firstly, it's about the study to study about various types of physical layer attacks and optical networks. As I said before, we have studied the attacks which I mentioned. The attacks which we discuss are about the in-band jamming attack and out-of-band jamming attack and polarization modulation attack. So and the next thing is to implement the proposed model to by using OptiSystem software. So this we actually done in this review. We use the OptiSystem software and we propose the basic model about how the information is transmitted through the optical network, and how the intrusion signal or simply how the external signal that affects our information, and that reduces that simply makes the loss of information, and that affects the information. How it's affecting, we were able to see by using the software. We actually studied by using the software. And so and the next things which we're about to do are to collect data set by using these and by using simulations, and to explore machine learning algorithms for detecting and identifying these physical layer attacks. And finally, to find the accuracy of ML classifiers, since we have many ML classifiers, we will find the accuracy of which ML classifier is performing really well by using the OPM parameters, the optical performance monitoring parameters. Yeah. So next, yeah. So this is the proposed methodology. This is the phase one, and in the phase two, we'll be doing the machine learning algorithm by which we can be able to detect and identify the physical layer attacks. Yeah. So we can see here the input signal and the intrusion signal, which is the external signal that gets that's getting entered into the optical fiber through which our main information is transferred by a coupler. It gets adding to our information, and through the polarization scrambler, it changes the polarization of our original signal, and then we can see the optical spectrum by using the optical spectrum analyzer. And from this optical spectrum analyzer, we will able to get the data, and then by pre-processing it and by using the ML classifier, we can get the output. Yeah. So this is the basic thing which we're able to do. And yeah, so from here my teammate Teja will explain the next one.
Hi, my name is Raviteja. My roll number is 108117029. As my teammate explained about our proposed methodology. Basically, in our proposed methodology, we have two parts: data preparation and machine learning part. So, in this for this review one, we implemented the part of in data preparation. So, after implementing this part for the review two, it will become very easy to collect the data set and applying machine learning algorithms. So basically in this project we are going to study about the two physical attacks, and we are going to detect and identification of these two attacks by using the machine learning. The two attacks are in attack due to the intrusion signal and the attack due to polarization modulation. Basically in practical scenario what happens is optical signal will travel through the optical fiber. Basically the communication from transmitter to receiver happens through the uh, channel. In the channel, the optical signal travels through the optical fiber. So whenever the optical signal traveling through the optical fiber, some intruder, some external source, due to some external source, some external signal will get included in the optical fiber. Due to this, these both signals, the input signal and the intrusion signal will get mixed up, and the output signal will become different. So what we are expecting will be completely different. So here the missing communication takes place. That means an attack has been taken place. This is one type of attack due to intrusion signal. Another type of attack is polarization modulation. So basically in the polarization modulation what happens is, basically in polarization modulation the polarization angle will become different after the modulation. So whenever the input signal travels due to some external source, some external part, the polarization modulation will takes place. Here due to polarization modulation, so the polarization angle of the input signal will become different. That means the output will be different compared to what we expected. So here the miscommunication takes place. That means what happens is, here an attack has been takes place. These two practical scenarios we implemented to get better understanding. We implemented experimentally. For the intrusion type of intrusion signal attack, we have taken two signals, input signal and intrusion signal. We have taken same sources, continuous wavelengths. But for the input signal and intrusion signal, the wavelengths will be different. So we are passing through these two input signal and intrusion signal to the 3dB coupler. Here what happens is, here mixing of these two signal will take place. What in practical scenario happens is same as like this, mixing of these two signals. Due to mixing, the output will become different. This is intrusion signal scenario. And the second scenario, when the input signal comes to the polarization combiner, here polarization modulation takes place. That means polarization angle of the input signal will become different. That means output will be different. This is the experimental setup of the practical scenario. In the simulation we are clearly shown this for the input signal. This is the input signal. We have continuous wavelength. Here the wavelength is different. Wavelength is frequency is 194.5 terahertz. Here this is the intrusion signal. Here the frequency we use is different. These both are same signals but different wavelengths. These two passes through the coupler. Due to this mixing of this signal, output will become different. In the graphs we can clearly see in the intrusion signal attack, the input signal is here, this one, and the intrusion signal is this one. Due to mixing of these two signals, the output will be like this. Here due to mixing of these two signals, and the power of the output signal will become different, and wavelength will be different, and bandwidth will be different. So that means the output will be completely different. So here the attack has been taken place. By collecting various samples like this, we will use machine learning algorithm for review. And for the polarization modulation, here in the polarization combiner, polarization modulation takes place. There are two inputs for the polarization combiner, and in one input we have taken as an input signal. That means the optical signal which passes through the optical fiber. For the another input we have taken the sine wave generator. Here we use sine wave generator to get modulation to be done. Whenever we use the sine wave generator, whenever switch on the sine wave generator, here the polarization combiner will combiner takes the modulation part. So here sine wave generator, this is electrical one. To convert this electrical to optical, we use the modulator. So after the modulation, we will get the optical input. These two are the optical inputs, because the polarization combiner accepts only the two optical inputs because it is an optical instrument. So in the graphs, we can clearly see that for the polarization modulation attack, this is the input signal. and this is the sine wave generated after the modulation. So whenever we pass through the input signal to the polarization combiner, what it does is it does polarization modulation. Due to the polarization modulation, the polarization angle of the input signal will become different. So here the input signal will be different. Due to this, power is changing. Wavelength is somewhat different compared to the previous one. That means the output will be completely different. So due to this, miscommunication takes place. This is the basic circuit to understand the basic process what is happening in the attacks. For the review too, we will explain about complete. We will implement this basic circuit, and we implement. We will for the review to implement the complete circuit, and we will collect the OPM parameters for different parameters. So after collecting the data set, we will apply machine learning algorithms. That means we will explore machine learning algorithms. These are the reference we have used. Thank you.